Hello, Geometry. This is 12.3, two-way tables and probability. So the main thing that we're looking at here is a table, basically. Table of values, but it's called a two-way table because you can look at the sums of the rows and the sums of the columns. So what we have here on this first exploration is a survey of 80 students. This is called the Venn diagram here. You should be a little familiar with. And the circles represent the groups of kids that fit in each category, and where they overlap is kids that would do both of them. So like the 25 is the number of kids who just play an instrument. 16 would be the number of kids who play an instrument and speak a foreign language. 30 would just be those who speak the foreign language, and then 9 would be those who do either of those. So transferring those over to this two-way table, remember the rows go across, so we have row 1 and row 2, and the columns go up and down, so we have column 1 and column 2. And then you have your totals. So that's your two-way. You can go across here or you can go vertically here by the rows or by the columns. So those who speak a foreign language and play an instrument, remember that was 16. Those who speak a foreign language but they do not play an instrument would be the 30. So if you go across, this right here is 46. That is the total for those who speak a foreign language. Okay, so these two columns break down how many fit into each of these categories, and then the total tells you how many speak a foreign language. Those who do not speak a foreign language, but they do play an instrument. Okay, so they play an instrument, but they don't speak a foreign language. That would be 25. And they don't do either. This is our 9 that's out here. So going across here, we have 34 who do not speak a foreign language. I can add these vertically, and I get 41. Those are the number of students who play an instrument. Okay, if you add 16 and 25. Those who do not play an instrument would be 39. That'd be the 30 and the 9. Do not play an instrument. Okay, so these categories, these are just taking these numbers and filling them in here. But this is what they call a two-way table. So when they're talking about a two-way table, they're talking about that sort of setup there. Okay, so a lot of different vocabulary that I want you to go through. Make sure you write this down. We just talked about a two-way table. And now I'm going to pull this back up, what we had on page 365. Joint frequency and marginal frequency. Okay, your joint frequency is each entry in the table. Okay, so that is in the table. So joint frequencies are each entries in the table. So here, let me get a different color here. These arrows that are red, those would be the values that are the joint frequencies. Okay, so those four right there, those are the entries. Those are your joint frequencies. Now your marginal frequencies are going to be these on the outside. So it can be that one, that one, that one, or that one. Those are referred to as your marginal frequencies. Okay. So the marginal frequencies are the sums of the rows and columns. Okay. So sums of the rows and columns. Those are your marginal frequencies. Now, here comes this word relative. Okay, that means in relationship to something else, and the definitions are down here. A joint relative frequency is the ratio of a frequency that is not in the total row or the total column to the total of the values or the observations. Okay, so if you want a joint relative frequency, you'd have to take, in this case, 16 over 46. So the joint relative frequency would be 16 over 46. You can get the decimals for those. This one would be 30 over 46. This would be 25 over 34. Now this is going based off of rows. You can also do this based off of columns, and then you take 16 over 41, 25 over 41, 30 over 39, and 9 over 39. And they will be specific to say, find the joint relative frequencies based off the rows or based off the columns. They'll tell you which one you want. Okay? So joint relative frequency, that is taking a joint frequency divided by the total from a row or column. Okay. So the marginal relative frequency, that is the sum of the joint relative frequencies in a row or column. So marginal relative frequency is the sum. That means you're going to be adding the joint relative frequencies, that's that, from a given row or column. Okay. The final is the conditional relative frequency. That is the ratio of a joint relative frequency to the marginal relative frequency. You can find a conditional relative frequency using a row total or column total of a two-way table. We'll see, and that is taking, so what it's saying is the joint relative frequency over the marginal relative frequency. So this is a joint relative frequency divided by a marginal relative frequency. Okay, so coming back, and when they're asking some of these are a lot of words. I had to kind of review these as well, but coming back and checking what do I have to do to find this. Okay, so keep this page handy. So complete the two-way table, exercises 1 and 2. So we have enough information based off what they've given us here. So we know 22 kids were tardy and they walked. We want to figure out how many were on time. How many walkers were on time? How many bus riders were tardy? How many bus riders were on time? We know that 58 kids were on time here, and 60 kids rode the city bus. Okay, so 130, let's work backwards here. So 130 has to be the sum of these two rows here. These two cells have to add up to 130. These two on this column have to add up to 130. So 130 minus 60 for up here would give us 70. 130 minus the 58 would give us 72. So we know there were 70 kids who walked, 60 who rode the bus, because there's 130 kids. 72 were tardy, yikes! 58 were on time, that adds up to 130. So let's get this here. If 22 walkers were tardy, that means 70 minus 22. So 70 minus 22, that'd be 48. 48 were on time. So the city bus, let's work down this way. 72 were tardy. 72 minus 22 gives me 50. 50 of the bus riders were tardy. Something happened to a bus probably. And this would add up to 10. Okay, so we check. 22 plus 48 is 70. 50 plus 10 is 60. 22 plus 50 is 72. 48 plus 10 is 58. Everything adds up to that 130. Okay. Age and response, under 21, over 21. So under 21, 24 were no's. There's 25 total, so 1 had to be yes. 1 plus 29 is 30. Okay, so here, over 21, 25 under 21 responded. That means 50 over 21 had to respond. 75 minus 25. 75 minus 25 gives us a 50. 75 minus 30 gives me a 45 right there, which tells me this has to be 21. 50 minus 29, or 45 minus 24. Okay. Survey was taken of 100 families with 1 child and 86 families with 2 or more children to determine whether they were saving for college. Of those, 94 of the families with 1 child and 60 of the families with 2 or more children were saving for college. Organize these results in a two-way table, then find and interpret the marginal frequencies. Okay, so here comes our two-way table. So I need a 2x2 box, and then I need totals. So look what ends up being there. Here's another total. Actually ends up being a 3 by 3. Darken that in a little bit. Okay. So we have 100 families with one child and 86 families with 2 or more children. So we have family size, we could have 1 child or we could have 2 plus. There we go. 1 child or 2 plus. And then we're asking, are they saving? Yes, no. So we have 100 families with 1 child. So that has to be 100 right there. 86 families with 2 or more children. So we have to have 86, so we have 186 families. Determine whether they're saving for college. Of those, 94 of the families with 1 child and 60 of the families with 2 or more children were saving for college. So yes, they were. So 94 were, which means 6 weren't, and 60 were, which means 26 weren't. So altogether, that adds up to 154 and 32. So 154 are saving for college, 32 are not. Okay, so this is your two-way table, and now they want. So this is our total right here, and we're going to use this total to help us with our marginal frequencies. Okay, this is an error I worked on a little bit earlier, but we'll fix it here. So this total is what we're going to use for our division here to find these percentages. Okay, so check over here, joint frequency. It's total from, this should be, say, the table. This is the total from the table. Joint relative frequency is each joint frequency from the total on the table. So if I'm looking for this one right here, the relative frequency would be 94 divided by 186. This is out of the total. 94 divided by 186. I can't see that there. You get 0.505. So this is about 0.51. Sorry for the small stuff in there. So it'd be 0.51. Here, the next one, this would be 6 divided by 186. 0.03. That'd be about 3%. 3% of the one-child families of the total were not saving for college. 51% of the families were. 60 divided by 186 would be 0.32. Use a red color. Maybe I'll stand out better for us. 0.32. And then 26 divided by 186 is 0.14. Okay, they may want you to go a few more decimal places. We'll go with that for now. Okay, so these are the relative frequencies, these 4 in here. To find the marginal frequencies, we're going to just add them across. So this is 0.54, 0.46. Coming down, this is 0.83, and this is 0.17. So what this tells us, remember, this is one child. 54% of the one child of the families were one child. So 54% of the families surveyed have one child. Okay, 46 have 2. Notice 54 and 46 add up to 1. That'd be 100%. These should always add up to 1 here. So 46% of the families had 2 plus children. 83% of the families were saving for college, and 17% of the families were not saving for college. Okay, and it breaks it down by which ones are which there. Okay, let's try this again. So in a survey, 214 ninth graders played video games every day of the week, and 22 ninth graders did not play video games every day of the week. Of those that played the video games every day of the week, 36 had trouble sleeping at night. Of those that did not, 7 had trouble sleeping at night. Make a two-way table that shows the joint and marginal relative frequencies. Okay, so we have ninth graders, 214 ninth graders. Make a 3 by 3 chart here. And I know I have 214 ninth graders. Oh. No, that's the ones who played video games every day of the week. So every day. Yeah, I'm making mistakes too. That's why I should not use pen on your homework. So every day they played games, and not every day were 22. So altogether we have 236. That should be our total there, 236 ninth graders. Of those that played every day of the week, 36 had trouble sleeping at night. So trouble sleeping was 36. And no trouble sleeping, that would make 214 minus 36, 178. Okay, of those that did not play every day of the week, 7 had trouble sleeping at night. So 7 had trouble sleeping. That means 15 did not have trouble sleeping. So 36 plus 7 gives us 43 are having trouble sleeping. 178 plus 15 is 193. 193 do not have trouble sleeping for freshmen. Okay, so this kind of gives you the table, the breakdown. Those who play every day and have trouble sleeping, those who don't have trouble sleeping will play every day, and then not every day but trouble sleeping, not every day and no trouble in the totals. So your frequencies, we get a bigger one here. Okay, your frequencies should always add to 1, 100%. So every day, not every day, our labels can be better if we had to be professional here. And trouble sleeping, and no trouble sleeping. So you're going to start with these 4 right here, and you're going to take this value, 36, over the total, 36 over 326, or 36 over 236. So 36 divided by 236 gives me about 0.153. This one would be 178 over 236. This is 0.254, 0.754. Down here, this would be 7 divided by 236. And that is 0.030. And then 15 divided by 236. That'd be 15 over 236, 0.064. So add them across. 0.153 plus 0.754 would be 0.907. 0.03 plus 0.064 would be 0.093. 94 rounding issues. Okay, these should add to 1 that would be close if we didn't have the rounding issues. Okay, coming down, this one would be 0.183. And this one would be 0.818. Okay, again, they should add up to 1. If we didn't round them earlier, they would have rounded to 1. Okay? I think if you go to 2 decimal places, things have a better chance of adding up here. Okay, but what this means is 90% of the kids play video games every day. Okay? And about 9% of the kids, and 10%, don't. 18% have trouble sleeping at night, 81% do not. Okay. So number 5, last example for this. I do encourage you to look through the examples in the book as well and work through those. Those are also on the Big Ideas one. But for financial reasons, the school district is debating about eliminating computer programming class at the high school. Don't do it. The district surveyed parents, students, and teachers. So 3 categories here. The results given as joint relative frequencies are shown in the two-way table. Okay, what is the probability that a randomly selected parent voted to eliminate the class? Now you notice the marginal relative frequencies are not in here. Okay, so we want to do that first. We want to fill in how many parents total were interviewed here. So this would be, if I add these together, I get 0.66. Add the students together, I get 0.23. At the teachers, I get 0.13. If I add those together, that'd be 89, not quite 1. Again, we have some rounding issues there. 58 plus 6 is not 66. That'd be 64. There we go. There's my issue. Okay, if I go across, the number of yeses would be 6876. 0.76, 76% said yes, and the no's should be 924. So 24% said no, we should not eliminate it, and 76% said yes, we should eliminate it. Okay, 64% of those were parents that responded, 23% were students that responded, 13% were teachers that responded. All of these should add up to 1. So the probability that a randomly selected parent voted to eliminate the class. So here were our parents, voted to eliminate it. So we need the probability that they voted yes, given they're a parent, divided by the probability that they're a parent. So what that takes is that just takes the 0.58 divided by the 0.64, and you get 0.906. So about a 91% chance you get a parent who voted to get rid of the class. So if you're making random calls, you'd have 91% chance you get someone that was in favor of canceling it. The probability that a randomly selected students did not want to eliminate the class. So the probability that you have a no, given that you're a student, over the probability that you're a student. So that would be 0.15 divided by 0.23, 0.15 divided by 0.23, and you get about a 65% chance. Okay? Determine whether voting to eliminate the class and being a teacher are independent events. Well, the probability that you voted yes to eliminate the class is 0.76. Okay? The probability that you're a teacher is 0.13. These are not equal, so they are independent. Okay, just to find the probability of each one. Okay, so those are the examples out of the student journal for 12.3. There are more examples that I encourage you to look at in the textbook or on your ebook or on Big Ideas lesson website. So we'll see you soon.